Good morning, friends of class 11 science. Today we are going to learn about projectile motion. One projectile motion we have already learned, and now that was a projectile motion which was fired horizontally. Now this is yet another part of projectile motion, and this is basically a two-dimensional motion. Okay, so exactly what do you mean by a projectile? Projectile means something which is thrown into the air, which is given some initial velocity, and rest of the motion is done only under the influence of gravity. Okay, so let us start with the projectile motion. This projectile is fired obliquely from the ground. Now, how does this projectile motion looks like? From this point, you are firing the projectile, you are giving some initial speed to the projectile. What is that initial speed? That initial speed is u. Okay, and at what angle you are throwing the projectile? This particular speed or this particular velocity is given to the projectile at what angle? The angle with respect to horizontal is theta. Okay, now once it is fired, it will first move up and then it will move down. Okay, so you can very well see that this kind of motion, the mathematical path of this is known as parabola. Okay, so what kind of motion is this? This is parabolic motion. Now what are the parameters, the other parameters of projectile motion? See, air resistance is totally neglected. Okay, the only acceleration that is working on this, that is the gravitational acceleration. And what is the direction of that gravitational acceleration? It is equals to g. Its magnitude is g, and what is the direction? Direction is always downwards. So when it goes up, acceleration is downwards. That means it is retarding as it is going up, and when it is coming down, when the motion of projectile is downwards, acceleration is also downwards, so it is accelerating. Okay, so when going from ground to the top, it is retardation. Going from top back to the ground, it is acceleration. Okay, the initial velocity u and this angle theta, because I want to divide this motion into two different parts, into two different paths also. One is along x-axis, the other is along y-axis. Okay, so for that purpose, initial velocity u is resolved in x direction and in y direction. What is the initial velocity in x direction? What is the velocity given to the projectile in x direction? It is u cos theta. Okay, this is u, this is theta, so adjacent part becomes u cos theta. The perpendicular part becomes u sin theta. So exactly what is happening? The initial speed in x direction is u cos theta, and the initial speed in y direction is u sin theta. See how the two-dimensional projectile motion is divided into two different dimensions, x and y. Because there is no acceleration in x direction, the velocity remains constant. Do you know that if there is no acceleration, no retardation, then what happens to the speed of the particle? The particle keeps on moving with the same speed in the same direction. Okay, so along x-axis, what is the initial speed? It is u cos theta. In y direction, what is the initial speed? It is u sin theta. What is acceleration in x direction? There is no acceleration in x direction, so it is 0. And what is the acceleration in y direction? There can be two. retardation and acceleration. So it can be plus g or it can be minus g. This will be the acceleration in y direction. Okay, so this is the brief introduction of what exactly is projectile. And now what we are going to do is that we are going to find few things, not few things, we are going to find many things. And what are those things? See, the very first thing, we are going to find the time of flight. That means for what time or for how much time the projectile remains in the air. Okay, all right. Before I start telling you how do we find the time of flight, just one last thing. For this projectile motion, we combine two motions. दो motion को हम combine करेंगे. What is the first motion? The motion along x-axis, which is uniform like this. And the other motion is in y direction. How is that motion? While going up, retarding, and then coming down, accelerating. Okay, so first see, this marker is going to perform motion along x-axis. It's this. And now the same marker is going to perform the motion along y-axis, which is this. And now both x motion and y motion all together. See, I am going to move this marker with uniform velocity and then I am going to move it up and down, and all both these motions will take place simultaneously with this marker. See, uniform motion like this and up and down motion like this. So it is this motion. Once again, straight motion, up and down motion, दोनों को combine करते हैं. So it appears to be like this. And what is this motion? This is projectile motion. Okay, so time of flight. How do you calculate time of flight? I am taking an assumption in this. You can call it that now it is assumption, but it can be mathematically proved that the time of ascent and the time of descent of projectile, they are equal. That means the time taken by the projectile to go up and the time taken by the projectile to come down, they are equal. Alright, so time of ascent is equals to time of descent. This is my assumption. And now the fact is that when the projectile goes up, when it is at the top, सिर्फ इसके y motion पे ध्यान दो. Okay, सिर्फ इसके y motion पे ध्यान दो. It is going up and then coming down. What is the ascent motion? Fired from the ground and then going up. So at this point, when the projectile is at the top, what is the velocity in y direction? It is 0, because when it is at the top, it has to come down, and because it has to come down, it has to momentarily stop at the top position. So I have an equation of motion. V is equals to u plus at. I am rewriting this equation of motion for y-axis. So velocity along y direction, initial velocity along y direction, time is the time of ascent, and because initial velocity is in upward direction, it is taken positive. Acceleration will be in the downward direction, it will be taken as negative. So I have taken as minus g. Okay, v is equals to u plus at, v is equals to u plus at, the same equation written for y motion. What is the velocity at the top? It is 0. What is the initial velocity given to the projectile? It is u sine theta. Okay, what is the acceleration? It is g. And what is the time? It is the time of ascent. So from here you can find the time of ascent. U sine theta ko वहां ले जाओ, g को नीचे ले आओ. Okay, so time of ascent is equals to u sine theta upon g. Okay, but the total time of flight of projectile will be time of ascent on plus the time of descent, or you can say the total time of flight is this plus this, but they are equal. So to find the total time of flight, I have to multiply the time of ascent by 2. one going up, second part coming down. So simply multiply this by 2, it is 2u sine theta upon g. Okay, this is the time of flight of projectile motion, and this is how it is calculated. Now coming to the next parameter, that is the maximum height of projectile. Maximum height of projectile. What I am finding? I am finding this. ठीक है, ये projectile आपका कितना ऊपर तक जा सकता है, that is the maximum height attained by the projectile. I am again using one equation of motion, v square minus u square is equals to 2as. Familiar equation? Okay. Now again, at the top, when the projectile is at the top, what is the velocity along y-axis at the top? It is 0. Using this equation, rewriting the same equation for y-axis, vy square minus uy square is equals to 2a, that is acceleration, it is minus g, and what is the distance covered? Distance covered will be equal to maximum height. जब projectile top पे पहुंचता है तो y-axis में कितना distance cover कर चुका होगा? It will be covering a distance of h. So distance covered equals to h. Put the values. Vy equals to 0. At the top, initial velocity u sine theta, so this becomes u square sine square theta is equals to 2gh, and from here simply transpose 2g on the other side. So what you get is h equals to u square sine square theta upon 2g. Simple. Maximum height. And now coming to the range of projectile. What is the range? The distance covered on the ground is known as range. You can see this is the range of projectile. यहां से measure करना शुरू करो, यहां पे आओ, the distance covered, that will be the range of projectile. Okay, now tell me or guess yourself, what will be or on what motion does the range of projectile depends? Does it depend on y-axis or does it depend on x-axis? Such as time of flight, it depends on what axis? It depends on y motion. Okay, देखो x motion में क्या होगा? x motion में the projectile is going through a constant speed. So if you just notice that because there is no force acting in x direction, the x motion of the projectile is never going to stop. ओके अगर आपको किसी चीज के मोशन को रोकना हो तो आपको उसको रिटार्डेशन देना पड़ता है. इज देयर एनी रिटार्डेशन अलोंग एक्स एक्सिस? देयर इज नो रिटार्डेशन. सो इन थियरी व्हाट will be the range of projectile? The range will be infinity. Why? Because projectile x direction में रुकेगा ही नहीं. क्यों नहीं रुकेगा? Because there is no acceleration, there is no force acting on the projectile in x direction. But the thing is, because its y motion comes to stop, जैसे ये ऊपर जाता है फिर नीचे आता है, जैसे जमीन से टकरा जाता है मोशन खत्म हो गया. ओके, सो इसका टाइम ऑफ फ्लाइट x मोशन पे डिपेंड करता है? नहीं करता. देन ऑन व्हाट डज इट डिपेंड? इट डिपेंड्स ऑन y मोशन. इट डिपेंड्स ऑन y मोशन बिकॉज the moment y motion stops, the x motion will also stop. So time of flight depends on y motion. Maximum height attained by the projectile, on what does that depend? It again depends on y motion. Range of projectile depends on x-axis. Okay, now how to find the range of this projectile? What is range? Distance covered along x-axis. On what? What is range? Distance covered along x-axis. What is the type of motion taking place along x-axis? It is uniform motion. And for uniform motion, I have only one equation. Speed is equals to distance upon time. Or I can say distance is equals to speed into time. Okay, writing this for x-axis, time of flight, the total time in which the distance must be covered should be equal to time of flight. ठीक है ना? कितनी देर तक projectile x direction में motion करता रहेगा उसके time of flight तक. So here the time will be equal to t. Just put distance covered along x-axis equals to the range. Initial velocity along x-axis is u cos theta, and time of flight 2u sin theta by g, that we have already found over here. 2u sin theta by g. इसको यहाँ put कर दो. Okay, u into u makes u square, 2 sin theta and cos theta. So what is the range? U square 2 sin theta cos theta equals to g. And the final thing, see this term 2 sin theta cos theta, this term, this is the trigonometric expansion of sine 2 theta. If I want to expand what is sine 2 theta, I can write it as 2 sin theta cos theta. So this is the final expression for the range, u square sine 2 theta upon g. So today we have learnt about projectile, the time of flight, maximum height and the range.